The kernel is a big part of how operating systems interact with the hardware in the system and other softwares as well. So you've probably heard of the kernel before, and it's not that kernel. That kernel is a little bit different. A lot of people actually do think like the kernel is spelt like that sort of kernel. It's not. It's spelt like KERNEL. So kernel. It's like a popcorn kernel essentially, but it's a core part of the operating system. The operating system uses the kernel to sort of manage system components and tasks. So if an operating system is asked by a user to say open a Word document, it's going to know, right, we need to go into long-term storage, put that into RAM. So maybe a Word document from RAM into from this long-term storage into RAM, so the CPU can then deal with it. And then obviously it might get sent to the graphics card so it can be put on screen. Like the operating system will have this built in, which that is the kernel. So it says, right, you systems need to do this in order for this software to work correctly. Um, Obviously, because it controls multiple different components and it performs different tasks, it's it's essential that all softwares use the kernel in order to interact with devices. Now, if you've got a gaming PC or know anything about sort of consoles or have tried setting up a your own sort of homebrew games console or anything like that, um, a lot of places will have their own set of commands for the kernel to interact with their device. So a graphics card, say like Nvidia's or AMD's, they will have their own software that will add commands to the kernel saying this is how you use the graphics card that you've got in your computer correctly. So it depends on what it's for. There can be software for your CPU as well, telling how the kernel how to optimize it better to use essentially for other pieces of software on your system. So the kernel has got core functions in the OS, and the OS will try and run it as best as it can. But obviously, you can add other things like drivers, and drivers alter how the kernel work in order to, make components work a lot better alongside other components and with software that's on the system. So obviously, as you can see, applications will use the kernel, and then it might use multiple different devices. That's basically how it works in a nutshell. Um, Obviously, with the kernel, it can do multiple different things, and yes, you do need to remember these. So please, please, please revise these and make sure you remember what they are because you may be asked it in your exam. But so the kernel will obviously have program execution, so it's able to load software, allocate resources, and then run the actual program, and then obviously finish it. So that's pretty straightforward. You probably already know that anyway, because that's what the computer does. It loads software. It thinks, right, what do I need in order to run this software? Runs what it's been asked to do, and then it'll stop it unless told otherwise. That's how most programs work. Interrupts, again, we'll be going over this when we do computer architecture, but interrupts are used for stopping what the CPU is currently doing and responding to a user request. So when I move my mouse on screen, I'm interrupting the CPU potentially, I don't know, doing a virus scan in the background, and me moving my mouse. So it'll be like, right, the user's wanting to move their mouse, let's move their mouse first, and then we can carry on. But because CPUs are so quick now, you don't notice there's any difference. Like, I can't tell my mouse has been slowed down whatsoever. Um, Now, when we're talking about the third point, so modes, modes are used to sort of. What's the best way to sort of describe this? It's to change between certain different operations. So it might be that you will have, say, oops, that's my fault, didn't mean to do that. Get back to where it is. There it is. It might be that you've got a system or some piece of software that wants to use sort of memory or storage, so RAM or hard drive, and it needs to know like how to basically run a piece of code. So your code might say, right, I want to retrieve something from the hard drive, but it might be written in something like Python or JavaScript or C or C Sharp, any of the programming languages. And what it will do is it'll interpret that program language, switch modes, so it goes, right, it wants to load a file from um, the hard drive, switch it to this other code, which the hard drive will understand and know, right, I need to fetch this across. So basically, it's like a converter. The best way to sort of describe it is, say the program is written, and I'm not saying there is a programming language like this, I'm just giving this as an example, but say the computer uses French. It might be that the hard drive and the kernel uses English in order to focus correctly. So what the kernel will do is take the programming language that's in French, change it to English, so then the hard drive knows exactly what to do. And it's same with coding, so it'll be in C, it'll change it to assembly code most probably, because assembly code's the most low level programming code you can get, which computers and hardware will understand, and then it will perform an operation depending on what it was told to do. So when it's switching between modes, it's basically switching between what what a program says and what the kernel will do with it. Essentially, it's switching between the program and what the kernel interprets it at. Um, Obviously, the kernel will get it usually spot on correct, but there will be means and ways to optimize it so it will run it better, because you could load a file from a hard drive, but it might be that you have you say, right, find it on the hard drive, load it into memory, we'll use it later, and then we'll perform some other operations first. Say it's a program that's loading a file, and then gives out a message, and then puts it on screen afterwards. It might be that you can optimize that code so it just prints the screen message first and then just brings that file straight onto the screen. That's just a generalization, but that's basically what that's talking about. If you think that I've not explained modes very well, let me know and I will explain it better in class, because obviously some things are going to be quite abstract, especially when it's just theory, because you can't actually physically show this on screen usually. So please let me know if you do need help with it. Again, memory management is fairly straightforward. It's just saying what the RAM allocates to different programs. So it might say, right, this program might need say like 5 gigs worth of RAM. And that's actually it. So that's quite easy. It's just saying like, right, how much RAM does this need in order to work correctly, and we'll manage how much memory each thing should get. That's pretty straightforward. Now, obviously, with this, there are other points to it. So device drivers, we've sort of already mentioned. It allows it to communicate with hardware components, but can squeeze the best sort of features and performance out of it. That's what I was talking about earlier in terms of drivers, changing the kernel so it can run it a lot better on your computer system for software to use. Multitasking, obviously, your PC will allocate CPU runtimes for programs. So it will be like, right, run Microsoft Word, run the internet, run a browser, run a game and stuff like that. But each one will get so much CPU time. The best way I can sort of show that, actually, if we go to full screen and I show you this. So this is obviously a task manager. As you can see, the CPU's got different things running. Now, my Streamlabs, which is recording, that's taking up most of the CPU, because obviously it's requiring a lot in order to project this on screen, my sound and stuff like that, and that's taking up most of the CPU, whereas other things are running, but they're not requiring as much CPU power. So when we're talking about sort of this with multitasking, that's what it's talking about. So basically being able to run multiple different programs at the same time, and obviously peripherals like mice and keyboard will also get some CPU time as well, because obviously need that to put inputs into your computer. Disk access, I mean, I don't really need to read that. We've gone over storage so much, I'm not even going to bother with that. File systems. So file systems I'll how to put this. They control how data is stored. I know that sort of says it there, but it sort of knows, right, this is where it is on the hard drive, and this is, where a file is on the hard drive. This is where you can save a new file without overwriting it. So the kernel will remember where everything is on the hard drive, and be able to recover things from the disk, and obviously write onto the disk correctly as well. Obviously with USB drives it depends. USB drives, they will have their own sort of mini kernel, which will tell the main kernel how to find things on it. So that's why you can sort of plug and play things in. That's how it works. I'm going to explain this a lot better for file systems. So if we have a look, and I'll change it so you can actually see it on screen. Let's have a look. Browser. There you go, you can see it. If we have a look at a hard drive, and then the sectors on a hard drive. So a hard drive is split up into sectors. And it's split up into magnetic strips, as we've sort of mentioned in previous weeks. The kernel will remember where everything is on this disk. So as you can see, sort of where C is pointing to, it might be that this file's being read currently, but it might think, I need to store this in D later on. So if you made a change and then you want to save a new version of it, it might store it in D. The kernel will remember this. That's the whole point. The kernel will know where to put things and how to allocate it onto the disk, and work with softwares in order to, work correctly. Without the kernel keeping track of all that, you wouldn't be able to find any of this. You'd have to literally manually search through the disk to find stuff yourself. The kernel is there to obviously remember everything for you. I know that this has been quite a long video. There's a lot to do with the kernel, so I would suggest that you revise this, and if you've got any questions about it, please do ask me in class, because it's not the easiest thing to get your head around. There's a lot of different parts to it, but I'll probably put up a list somewhere so you can sort of get how many different things of the kernel there is, and have a list of what features are on it. But you need to get the main concept of what the kernel is and the main features that it brings. So hopefully this video should clear that up. As I say, if you've got any issues, let me know. Drop me a message. I'll do it in class, anything like that, and I'll sort it. So hopefully you should understand how the kernel works and its main features.